So for calculating standard deviation of group data, we can use a formula that's very similar to the formula we used previously. So standard deviation is equal to the square root of the sum of the frequencies times the data values minus the mean squared. And you take the sum of that and you divide it by the number in the group. And if it's a sample, you divide by n minus 1. But you only have to use that. I won't try to trick you. If it says sample in the question, use a sample. If it's population, use the population. Okay, so here we're not. A railway line gives out a small bag of peanuts to its travelers, and each bag does not always contain the same number of peanuts. The following table represents the number of peanuts per bag in 31 bags on a train. So you could make the argument that this is a sample, but we'll treat it as the population of peanuts on the train. So we'll use the regular, we'll divide by n instead of n minus 1. So to calculate the mean, you take the sum of the frequencies times the data value, and then you divide by the sum of the frequencies. So for example, in this case, we're going to do 2 times 28, which is the frequency times that data value, and then we add 5 times 29, so this is from the table, and we divide by 31. Again, you could make the argument that this is a sample and divide by 30, which would create a standard deviation that is a little bit larger. So you get a mean of 30.4 peanuts per bag. So now, if we're going to calculate the standard deviation, we can use our chart that we used, similar to what we used previously. So you take the data value, subtract the mean, which we calculated before as 30.4. And so when you do that, you get these values. And then if you square each of these values, you get the following. And then you've got to multiply the frequency times our x minus x bar squared. And you get those values. So now what you do is, to calculate the standard deviation, we take the sum of this column and divide by n. So in other words, here's the sum of the column, divide by n, and then you take the square root. And again, n would be 31 here, or 30 if you considered it as a sample, and you get a standard deviation of 1.18. So if we take a look at how the standard deviation relates to the data, we can calculate what one standard deviation above the mean is. And we take the mean and add one standard deviation to get 31.58. 2 standard deviations above the mean would be 32.76, which is basically 30.4 plus 2 times 2.18. 3 standard deviations above the mean would be 33.94. And as you can see, the bag with the most peanuts in it, there was one of them, and it had 33 peanuts, which is pretty close to 2 standard deviations above the mean, a little bit above. And then, so if we take a look at what 1 standard deviation below the mean is, you get 30.4, subtract 1.18, which is 29.22. And 2 standard deviations below the mean would be 28.04, which is really close to the fewest number of peanuts that actually were in a bag. So 3 standard deviations below the mean would be 26.86, which there were no bags of peanuts with that many peanuts in it. So the bulk of the data is located within 2 standard deviations above the mean down to 2 standard deviations below the mean. There are a couple that lie just barely outside of that, but most of the data, most of the values are located within 2 standard deviations above the mean.